Okay, we're going to do a few more definitions and then start doing some problems together. Okay, here are the definitions we still need. Number one, an outcome is in the union of A and B if it is in A or in B, where A and B would be two events. Okay, and the symbol for union of A and B is this. Okay, so let me give you an example. Suppose you're rolling a die. Okay, what is the sample space? What is the set of all possible outcomes? If you're rolling a die, the sample space is, you can roll a 1, a 2, a 3, a 4, a 5, or a 6. So that's the sample space. Okay? So let's say that A is the event you roll an even number. Okay? Let A be the event of rolling an even number. Okay, so let's write that down. A would look like this. Okay, now let B be the event of rolling a number greater than 3. Then what would B look like? B would look like this. Okay, so now the union of A and B would be what? Let's write it down. The union of A and B would be the event of rolling a number that is even or is greater than 3. And what would it look like? It would look like this. A union B, we write that way, and then it would be the set of all numbers that are even or greater than 3. So 2 would be in there, and so would 4, and so would 5, and so would 6. Okay, and the key word for union is the word or. Okay? All right, now a new definition. The word intersection. An outcome is in the intersection of A and B if it is in A and and B. You see, the key word for intersection is the word and. The key word for union is the word or. So let's look back at our example here, and let's write down what would be the intersection of A and B. And that would be the event of rolling a number that is even and greater than 3. Okay, intersection and go together. Oh, I forgot to show you the symbol for intersection of A and B is this. Okay, so in this example then, we would say the intersection of A and B is the set of outcomes that are even and greater than 3. So that would just have 4 and 6 in it. Okay? Okay, and one more basic definition is complement. An outcome is in the complement of event A if it is not in A. And the symbol our book uses for that is an apostrophe, but we say prime. We say A prime or A complement. Okay, so let's go back down here. If A is the event of rolling an even number, then what would be the complement of A? The complement would be the event of rolling a number that's not even. So in this case, it would be odd. Complement of A would be the event of rolling a number that is not even. Okay, so the word complement often goes with the word not. It doesn't have to though, because instead of saying not even, I could have said odd. Okay, so what would it look like? It would look like this. A complement equals the set of outcomes that are not even, so that would contain 1, 3, and 5. Okay, so that's union, intersection, and complement. Okay, now getting into a little bit more math here, we're going to actually start calculating some probabilities here. Okay, this is, I want to talk about something called conditional probability. Okay, so suppose we have two events, A and B. Okay. All right. I just want to remind you, the probability of A is denoted by this. You rewrite P of A, okay? And the probability of B is P of B. All right. Now I want to show you this new thing which is called conditional probability. So the probability that an event, I should say an outcome really. I'm going to word it the exact same way it is in the book. The probability that event A will occur given that B also occurs is, okay, so first of all, the symbol for that is this. We write probability of, and then we write A, vertical line B. So that is the probability that A occurs given that B also occurs. Okay? So let's talk about what does that mean for a minute. If we want to use the examples up above, we can do that. Just remind you here. The examples are that we're rolling a die, and A is the event of rolling an even number, and B is the event of rolling a number greater than 3. So in that case, if I write P of A given B, that's what we say when we read that. The probability of A given B. Okay, so that would be the probability of rolling an even number if the number you roll is greater than 3. Okay. Now, what would that equal? Let's go ahead and write down some probabilities. What's the probability of A? I did not write that down up above. I wrote down what A is, but I didn't write down its probability. So let's think about how do we calculate probabilities. If you remember from the last lecture, the probability is the long-term relative frequency. That's what the probability is, the long-term relative frequency. Okay, so if you want to calculate the probability of A, it's easy to do so. Look at A and look at the sample space. There's A, and here's the sample space. Okay, A has 3 what we call elements. There's 3 things in A. And there's 6 things in the sample space. We say the sample space has 6 elements. So what's the long-term relative frequency of A? It would be 3 divided by 6. Okay? The frequency of A would be 3. The relative frequency of A would be 3 over 6. And when you roll a die, you won't necessarily get an even number 3 out of every 6 times, but in the long term, you would expect that. So the probability of A is just the number of outcomes in A divided by the number of outcomes in the sample space. So that would be 3 divided by 6, okay? That's the probability of A in this example of rolling a die, which we should reduce. So it's a half, or if you prefer decimals, it's 0.5. Okay? Let's practice that with B. Let's find the probability of B. Again, that's just the number of outcomes in B divided by the number of outcomes in the sample space. B also has 3 outcomes, so that probability will also be 3 over 6, which is equal to a half, or if you prefer decimals, that's 0.5. Okay? Let's practice finding the probability of their intersection and union. Let's do that practice. There's the union. Here's the intersection. So let's go up and look at those two. The union of A and B has 4 elements. The sample space has 6, so the probability of the union of A and B occurring is 4 over 6, or 2/3, or 0.3 repeating. Now I will not accept any other decimal other than 0.3 repeating, okay? The homework might let you round off. You'll have to read the directions on the homework. Okay, but on an exam, if it's, I'm sorry, it's not 0.3 repeating, it's 0.6 repeating, sorry. But on an exam, if the answer is a repeating decimal, then you need to write a repeating decimal, unless the directions say to round off. Okay, let's do the probability of A intersect B. That's the intersection of A and B. Okay, here it is right here. How many elements does it have? 2. So that probability will be 2 over 6, or 1/3, or 0.3 repeating. Okay, now let's practice this new one that we just wrote down, which is the probability of A given B. So that is the probability of A occurring if you already know that B is occurring. So it's like I roll a die, okay, and I ask you, okay, what's the probability of giving an even number? So that's the probability of A, and you would say it's 3 over 6, or 1/2. But now, what if I roll a die and I cover it up, I don't let you see it, but I say to you, okay, I'll tell you what. I will tell you that I just rolled a number that's greater than 3. What is the probability that it is even? So what I did by telling you that I rolled a number greater than 3, it's kind of like I have narrowed down the sample space. So that I've said the sample space now, because I told you I rolled a number greater than 3, it's kind of like I'm saying the sample space is now just the numbers greater than 3. And I'm asking you, what's the probability that I rolled an even number? Okay, now be careful. It's not going to be 3 divided by 3. No, not at all. Ask yourself this question. How many even numbers are in B? two of them. If I tell you that B happened, and I ask you what's the probability that A is also happening, knowing that B happened, then we can look in B and say there's 3 elements in B, and 2 of them are also in A, and so the answer will be 2 over 3. Oops, wrong color. Okay, or 0.6 repeating. Now, that might be a little bit confusing, right? So I'll tell you what, there's an easier way of doing it. You don't have to, you can, but don't have to do what I did up here, where I changed the sample space to B, and then I circled how many things are in B that are also in A. There is a little bit easier way to do it. Let me just go back to the original highlighting. Okay, so what you can do, this is really the same thing, but it's just a little bit easier to think about it this way. You can take the probability of A and B both happening. What's that called? That's called the intersection of A and B. And divide that by the probability of B. Okay, let me write that down. I never finished up here. I'm going to write that down here. So the probability of A given B is equal to the probability of A and B. Remember, the word and goes with intersection, divided by the probability of B. So let's do it that way instead, because I think it's easier that way. Let's go down here. Okay, we just write the probability of A and B, that's right here, the probability of A intersect B divided by the probability of B what happens? The 6's cancel out and we get our 2/3, which is what I had gotten the first time I did that problem. It's just that I had to do that weird explanation of saying change the sample space to B and then do that stuff, okay? So it's easier to just follow this formula and just say, here it is again, the probability of A given B equals the probability of their intersection divided by the probability of B. Okay? Now, what I just highlighted there in yellow, of course, that also leads to something else. If you multiply both sides by the probability of B, we could also say this. The probability of A intersect B is equal to the probability of A given B times the probability of B. And that's useful to remember sometimes too. The book calls that the multiplication rule. I'll write that down further down at the bottom. I'm going to erase it from here and let's go write it down. The book calls this the multiplication rule. That the probability of A intersect B equals the probability of A given B times the probability of B. And the book also has a rule that it calls the addition rule. which says the probability of A union B equals the probability of A plus the probability of B, take away the probability of their intersection. Okay? So those are useful to remember. All right, let's do another example. This one's right out of the book. Okay, it says the sample space of some experiment. They don't explain what the experiment is, but they tell us the sample space is all ordered pairs of two whole numbers, where the first one is from 1 to 3 and the second one is from 1 to 4. So they want us to first write that sample space down. Well, it would look like this. Don't forget to put these brackets. If you don't have those brackets, then you don't have it correct. I'm sorry, but that's just the way it is. Okay. Now we have in here ordered pairs where the first number goes from 1 to 3 and the second number goes from 1 to 4. So that would have 1, 1 and 2, 1 and 3, 1 and 2, 1. Oh, sorry, I already wrote that. I really meant to say 1, 2. Okay, and 2, 2 and 3, 2. What else? 1, 3, 2, 3, 3, 3, and 1, 4, 2, 4, and 3, 4. That would be all of the things in the sample space. Okay, it says A is the event that the sum is even. B is the event that the first number's prime. Write down A and B. So A would look like this. Which of those two, I mean not two, how many are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 ordered pairs. Which ones have even sums? I don't know how they expect us to fit it in here. It's not going to fit. But 1 plus 1 is even, so that would be there. And 3 plus 1 is even, so that would be there. And 2 plus 2 is even. And 1 plus 3. And 3 plus 3. And 2 plus 4. So those ordered pairs would be in A. The sum is even. B is the first number is prime. I'll do that in another color so we can keep them separate. Okay. So which ordered pairs have the first number prime? I see 1, 1 and 1, 2 and 1, 3 and 1, 4 and 3, 1 and 3, 2 and 3, 3 and 3, 4. So there's B in green, and in blue is A is in blue. Okay, what's the probability of A? Well, count them. A has 6 elements and S has 12. So the probability of A will be 6 over 12, or 1/2, or 0.5. What's the probability of B? Let's count. B has 8 elements, and the sample space has 12. So the probability of B is 8 over 12, or 2/3. Or 0.6 repeating. It says, what's the probability of A union B? Okay, well, maybe we should write out, oh, sorry, that's not union. What am I talking about? That's intersection. Okay, so maybe we should write out A intersection B. Okay, let's do that in red. So that is the set of all outcomes that are in A and also in B. So I notice there's 1, 1. What else? 3, 1. Anything else? 1, 3. What else is in A and also in B? 3, 3. That's it. So what's the probability of A intersect B? There's 4 things in the intersection of A and B. There's 12 in the sample space. And so the probability of A intersect B, oh, what am I doing? Writing it on the wrong line. Sorry, this should be down here. So the probability of A intersect B is 4/12, or 1/3, or 0.3 repeating. Okay. Let's do in gray. Okay, we'll do this one. A union B. Well, this is going to be pretty big. A union B is all the stuff that's in A and also all the stuff that's in B, but you don't bother repeating anything that's already been written down. So I have 1, 1. First, I'm just going to look at what's in A. There's 1, 1. There's 3, 1. There's 2, 2. And 1, 3. And 3, 3. And 2, 4. All of those are from A. Now I want to throw in there as well anything that's in B that I don't already have written down. So that's going to add to there 1, 2. And 1, 4. And 3, 2. And 3, 4. So there's A union B. So now they want to know the probability of that. Let's count how many things are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of a total of 12. So that's 10/12, which is 5/6, which is 0.8 and then a repeating 3. Okay. Now, this screen's getting pretty full. I'm going to, well, we might need some of it. I guess I shouldn't erase anything. All right, it says, what's the complement of B? All right, I'm going to write that down below because it's getting really crowded up there. So B complement, okay, that's everything that's in the sample space but is not in B. So what would that be? That would be 2, 1 and 2, 2 and 2, 3 and 2, 4. That's everything in the sample space that wasn't in B. So what's the probability of B complement? Would be 4/12, which is 1/3, which is 0.3 repeating. Let's find A complement, because we're going to need that for the next question. A complement. That's everything from the sample space that's not in A. So that would be 2, 1, 1, 2, 3, 2, 2, 3, 2, 4. No, I'm sorry, that's wrong, not 2, 4. But it should have 1, 4. And also I should have 3, 4. There we go, that's A complement. So now look at question G. It says, what's the probability of A? Well, we already found that was 1/2. Let's actually do this. Let's write 6/12. And then it says plus the probability of A complement. That would also be 6/12. So we add those together, what do we get? We get 12/12, which is 1. Now, if you think about it, that has to be 1 because A complement is all the stuff that's not in A. So if you take the probability of A happening, and then you add the probability of A not happening, you're always going to get 1. Okay? All right, last question. H. What is the probability of A given B? So let's use our formula. That equals the probability of A intersection with B divided by the probability of B. We already have those written down. That's 4/12 divided by 8/12, which equals 4/8, which is 1/2, or 0.5. Okay? The probability of B given A, well, just use your intuition there with the same formula. It's just that it's B given A, so this time it'll be the probability of their intersection divided by the probability of, what will it be this time? This time it'll be the probability of A. So that'll be 4/12 divided by 6/12, which is 4/6, which is 2/3, which is 0.6 repeating. It says, are the probabilities equal? Well, certainly not. 1/2 does not equal 2/3. Okay. All right, I had a lot more planned, and if you look at the top, you see that there's a lot more in the title. We got to this, conditional probability, but we didn't get to this yet. That's okay. I'm going to leave it in the title. We'll get to that stuff in lecture 14.